Hello, my name's Austin McDaniel, and this will be my presentation on predicting airline customer satisfaction. I hope you enjoy. So, getting into the problem, the business problem that we're trying to understand, in fiscal year 2022, the Federal Aviation Administration reported that on average, 2.9 million commercial airline passengers per day flew in the United States. And so, where does this play into the business problem that we're trying to understand? New customer acquisition can be anywhere from 5 to 25 times more expensive than customer retention. And so, ultimately, what we're getting down to is, can we develop a model to predict customer satisfaction and increase the likelihood of repeat business, and specifically from loyal customers, which we'll get into here in a minute. But to do this, we're going to use the 7-step business analytics process and just go step by step through what we're looking at, and then how we are going to come to a solution, and then how we are ultimately going to implement that solution. So looking at the data set that we have, the data itself came from Kaggle.com, and it has almost 104,000 observations with 24 different variables. You can see the variables along with their descriptions listed on the right. Overall, this was a very well-structured data set. It was a secondary data set, just by the nature of the fact that we did not, or I did not specifically record these survey responses. But all of these to your right, or on the right side of the screen, are from a survey, a post-flight survey, asking the customers about their satisfaction on a couple of different categories, and then also just grabbing some data from the customers, such as gender, customer type, type of travel, age, etc. But you can also see the survey responses that were kind of more subjective to the customer, starting with in-flight Wi-Fi service and moving all the way down to cleanliness. Each of these was asked that the customer rate these a satisfaction level of 0 to 5, with 0 being not applicable, and then a 1 through 5 with an increasing scale of overall satisfaction from the customer. In the data set, there were 310 missing values. All 310 missing values were in the arrival delay in minutes, but we will talk a little bit later on why that's not going to matter in the next section, where we talk about kind of how we're picking the attributes. And then ultimately, satisfaction is the target variable. You can see that one at the very bottom of the table. And how this was recorded was effectively a binomial classification. So we've got airline satisfaction level, and then they were categorized as either satisfied or satisfaction, or neutral or dissatisfaction. So if they were so-so on the flight, or dissatisfied, those customers were lumped in the same group, and then customers that were explicitly satisfied were lumped into another group. And so we'll use that data ultimately to target satisfaction. And then, as we'll talk about a little bit more specifically, loyal customers, as we can see in the customer type, there's loyal and disloyal customer. What can we do to keep those loyal customers satisfied so that they bring their business back? Some attributes that were not included that could have been beneficial were attributes like one that I thought of would be price. So if we go back to this last slide, obviously you don't see price on there. But as you could imagine, the price of a flight could have a large role in the satisfaction of a customer. If a customer pays for a very expensive flight, they probably are also expecting good service. And so bad service in flight may negatively impact their overall satisfaction. However, on the flip side of things, the price of a cheap flight could outweigh the effects of poor in-flight service. And so that would have been an interesting variable to see how it would have played with the other variables that we have here. I don't anticipate that to be a large factor on the overall outcome of the model, but just something that, had we had developed a primary data set, could have been an interesting variable to look at. Now, looking at our data interpretation and our feature selection, here's just kind of a snapshot of what we are able to work with the data set. Looking through them with a mixture of Excel and RapidMiner, I didn't see any major outliers in the data set. However, there were a few, and you'll notice that one of the survey responses is circled there, and it's not an integer value. And so what I did here was, obviously, as we discussed on the previous slide, not applicable was a response. Going through the data set, there were several thousand responses that were 0. And so I kind of had the option, given that there were nearly 104,000 responses, I could get away with deleting any survey response that had a 0 anywhere in the response values, and still kept some pretty good integrity with the data set. However, I wanted to maintain as much data as I could. So how I did this was in each column, so particularly departure and arrival time satisfaction, which is this column right here, I averaged all the values that were 1 through 5. And so I did not include the zeros in the average of the column. And then I applied that average to any value that was a 0. So as you can see, this survey response for departure and arrival time satisfaction would have been a 0 or not applicable. They just didn't want to respond for whatever reason to this question. And so instead of taking that 0 and applying it to the data, which would have skewed it in a downward direction, I replaced it with the average value of a departure or arrival convenience response, which was 3.22. And I did that for all values that were given for not applicable. Another thing I did to look at the data was put it in a correlation matrix. So obviously we want to figure out which data points are highly correlated. Obviously correlation doesn't equal causation, but it is good to take a look. So obviously throughout the correlation matrix there are quite a few that are above 0.5. But a couple that I pointed out specifically or highlighted specifically were in-flight service correlated with onboard service. That had a correlation of 0.551. And as you could imagine, in-flight versus onboard, and because this is a secondary data set, it's kind of unclear what they're trying to get from that. And so for that reason, because there was correlation and they effectively sound like the same variable, I elected to exclude in-flight service. You'll also see that departure and arrival time delay in minutes, which is these variables down here in the bottom right-hand corner. Those are highly correlated as well with a 0.965 correlation value. And so for that reason, I elected to exclude arrival delay in minutes, which takes care of the 310 missing values that we previously talked about for the arrival delay in minutes. So that's why it wasn't a factor. Moving into the model development, I developed this model again with loyal customer data only. So after doing that, we were left with a little over 84,000 observations to work with. But I did that by filtering out all the disloyal customers. So I used filter examples to pick specifically the loyal customer observations, dummy coded the appropriate variables such as class type that was originally described as either business, eco, or eco plus. So dummy coding those polynomial variables so that we can get some kind of value out of it. And then of course setting our binomial value for satisfied or effectively not satisfied. Selecting the appropriate attributes and then splitting the data into a 70-30 training and testing split. 70% of that data, so of the 84,000, that's going to give you somewhere in the neighborhood of 60,000 observations, 60,000 observations to train the data set on with a logistic regression. And then another 30% of the data set to evaluate the results of that logistic regression. And then kind of as we alluded to with the response being binomial in nature, logistic regression seemed to fit the requirements of this model, given that we're really looking for a 1 or 0 value, satisfied or dissatisfied, and then ultimately looking at the performance. That's how we got to the model. And then next we'll look at how we evaluated that model. So looking at the confusion matrix, we can see that the accuracy was 89.13%, so pretty accurate. I was pretty pleased with the results there. And then just going through the values of the confusion matrix, you can see that this is all based on the testing data set, so the 30%. You can see that true, neutral, or dissatisfied, as in the customers that were actually neutral or dissatisfied. Of those customers, 11,926 the model accurately predicted as being neutral or dissatisfied, so an 89.55% class recall on that one. And then for the true satisfied, as in the customers were actually satisfied, it was able to predict 10,781 that actually were satisfied. And then it did miss 1,379, but still we got an 88.66% class recall on that and overall 89.13% accuracy. So I'm pretty pleased with the overall accuracy of the model. Next, we'll look at a lift chart that was created for the model itself. Really what this is showing you is that compared to what would have been a random distribution of the values, there were a little over 12,000 satisfied responses in the testing data set. And so of those 12,000, if you break them down into 10 bins, you would expect 10% of that to have approximately 1,200 positive responses or satisfied responses. But our model was able to identify 2,542 in the first bin alone. And then you'll look at the bottom here, the confidence for satisfied. If we take the first 3 bins, we still remain above a point or a 0.91 or higher in confidence that the customer is going to be satisfied based on their responses. So pretty nice lift chart to look at. Looking at the coefficients, so obviously with logistic regression, it's a little bit harder to explain the coefficients, but really what we can see from this is the coefficients represent the average change in log odds of a satisfaction with a single unit increase. So for each 1 point higher score that they receive on a satisfaction survey, the log odds of this coefficient are going to give you a percentage increase that the overall likelihood or overall outcome is going to be satisfied customer. And so the company could obviously use these coefficients to figure out which of these is going to have the largest impact, and i.e. the areas that they should probably focus the most on to increase or increase satisfaction or decrease the likelihood of dissatisfaction. And looking at the p-values over on the right side, 3 variables, flight distance, gender, and food and drink, all were insignificant. And so using this model for future application, I wouldn't recommend using these 3 as they just don't bear significance in the overall result of satisfied or not. And then again, reiterating one more time, this was made for loyal customers. So this same style of modeling could be used to identify disloyal customers, or maybe not so much disloyal customers, identify them, but figure out which variables are driving disloyal customers to be dissatisfied, and how we could kind of turn their business around and have them maybe turn into loyal customers or repeat business. Where we could take this model in the future, obviously, we could refine it with new survey results. So taking into account the time of year, price, as we talked about earlier, price of the flight, whether or not you're traveling with family, all these things could certainly be added to the survey responses to create a primary data set and then develop a model for future use. If I was going to recommend deployment of the model, I would definitely say to continue to validate the model based on survey responses, but to also identify the coefficients or the variables that are having the highest impact on customer satisfaction. And so if we can identify, say like the online user interface as something that has a large impact on whether or not a customer is satisfied, maybe we could drop some money into developing a better online user interface, and then boost our satisfied customer results way up with potentially not very much change. I would also recommend implementing just probably 1 or 2 changes at a time so that we aren't confusing the results of one change versus another. If we change too much, it's hard to pinpoint where exactly the increase or decrease in efficacy is coming from. And so I'd recommend probably starting with the most impactful variables and then isolating them, trying to figure out how they can improve the results of the model or of the satisfaction, and then move from there. So overall, that's the model that I was able to develop using the online data set from Kaggle. I hope that was clear and concise and answered any questions that you might have. Thank you for taking the time to listen, and I wish you all the best. Thank you.